So the thing to remember about one-sided limits is that you can just treat them as though it is um, a limit in general, a regular limit, most of the time. There's only going to be certain situations where it's going to cause an issue. So really, I can just go ahead and plug that 5 in as I run through these problems and see if I can get a value right away. And sometimes the same sort of things are going to show up that have in other samples or examples that we've done, where maybe I'm going to get 0 over 0 or something like that, or undefined, and then I have to figure out if it's approaching positive infinity or negative infinity. But best way to start, plug it in. So I have the opposite of 5 minus 5, which is 0 on top, over, before I plug this in on the bottom, I think I'm going to factor this because I can, and sometimes I can see something right away that I can maybe cancel out. So this is x minus 5, x minus 4. That's two numbers that multiply to be positive 20 and add to be negative 9. So negative 5 and negative 4. Negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9. So there's my factor. So I end up with here 5 minus 5 and times 5 minus 4, which gives me the opposite of 0 over 0 times 1, or 0 over 0, which I've said in the past, that's a red flag that comes up. That should be something that's like, whoa, okay, I should be able to cancel something out. And hopefully you saw that right away here when I did factor, that I was able to cancel that x minus 5 out. So once I cancel that out, I can just go ahead and try my limit again. So I'm looking at the limit as x approaches 5 from the left of the opposite of 1 over x minus 4 is what I'm left with. And again, I'm just going to plug that right in. So it is, I'm going to ignore the fact that it's from the left right now, because it doesn't really matter. This is just a regular old function that I'm looking at. And so I will plug in that 5, and I get the opposite of 1 over 5 minus 4, which is the opposite of 1 over 1, or negative 1. And that's it. That's my limit. Again, it doesn't matter that it's from the left or from the right, because when I graph this function, it ends up being just this, the graph of this function 1 over x minus 4 with a hole in it at 5. And because this function right here is continuous around 5, meaning it's going to be a smooth curve, there's no issue around 5, it's just that hole there, that comes from being able to cancel that out. Both sides of the function are going to go to negative 1. Okay, so don't worry too much about the fact that it's from the left or from the right if you can plug it in and get an answer. Okay, so let's try the next one. Again, this is one from the right, so I'm going to go ahead and plug it in. I'm going to start by factoring this bottom, again, because I can, and I recognize that I might be able to clean this up a little bit if I do. And so two numbers that multiply to be 5 and add to be negative 6, x minus 5, x minus 1. And so I already recognize here that the x minus 1s are going to cancel out. But if I don't cancel them out, I get 1 minus 1 on the top, and I get 1 minus 5 and 1 minus 1 on the bottom, which gives me again a 0 over 0, or another red flag. So canceling that out right away is going to be helpful. So again, when I cancel that out, I end up with the limit as x approaches 1 from the right of the opposite of 1 over x minus 5, and I'll plug it in again, and I get the opposite of 1 over 1 minus 5, which is the opposite of 1 over, minus 5, sorry about that, which is the opposite of 1 over negative 4, or just 1/4. And so again, in these first two problems, I was able to find a limit just by plugging it in. I did have to take care of the hole that was in there by factoring. Okay, so now what happens if, when I plug it in, I don't get this indeterminate form. I don't get an undefined form. Instead, I don't get this sort of red flag form. Instead, I get an undefined form. So let's take a look at what happens there. I just have a little extra job that I need to do. So again, I'll start by plugging this value in, and it's the opposite of 2 minus 4 over. I'm going to factor this again, make my math easy. So two numbers that multiply to be positive 8, add to be negative 6. That's x minus 4, x minus 2. And so I'll plug that 2 in, and I get 2 minus 4 over 2 minus 2, which gives me the opposite of negative 2 over negative 2 times 0, which is 1 over 0, or undefined. Okay, so that's an issue. That's not the same as this indeterminate form. This is undefined, and this is where coming from the left or from the right is important. When you watch it on the Khan Academy videos, he always referred to it as unbounded. And some of you, I saw in your answers that you left it as it's just unbounded. But if it's from the left or from the right, I want to know where it's headed. That's what I'm looking for here. Where is it headed along that asymptote? And I understand that it either goes up to positive infinity or down to negative infinity, and I need to figure out which one, especially because I'm interested in a particular side, this one coming from the right-hand side. And so what I'm going to do is I'm going to go back here to my factored form, and it turns out again I can cancel something out, so I'm going to do the limit as x approaches 2 from the right of the opposite of 1 over x minus 2 is what I'm left with. And so now I need to check the right-hand side. And so this is 2 from the right is what I'm looking at. I'm approaching 2 from the right. So I'm going to plug in something that is just slightly bigger than 2. I'm going to do a test point of 2.001. And I really don't have to do the math too much. I just have to figure out what's going to happen. And so when I plug in 2.001, and I'm going to show you what that looks like, I get the opposite of 1 over 2.001 minus 2. What I'm really interested in is, does this value come out positive or negative? Because if it comes out positive, it's going to go to positive infinity. If it comes out negative, it's going to go to negative infinity. So I want to see what this value comes out to be. And so it's the opposite of a positive number on top. That's not going to change. 1 is positive. And then on the bottom, it's going to be 2.001 minus 2, which is going to be a really small positive number, but positive. And so I have the opposite of a positive divided by a positive, which means that I'm going to end up with a negative answer. And if I'm going to end up with a negative answer, that means that this limit is going to negative infinity. And so that's the actual answer that I'm looking for, that it's going to negative infinity, not that it's unbounded on the negative side, not that it does not exist, but because I'm coming from the right, I want to know where it's headed, and it's headed to negative infinity. So let's do another one like that, where we're checking to see where it's headed, positive infinity or negative infinity. So when I plug this in here, I'm just going to plug it in like normal, because I'm going to ignore right now. I'm going to pretend like I don't know that this is going to come up as undefined. I'm just going to plug it in and see if I get an answer. So this is the opposite of 2 over 5 squared minus 25, which gives me the opposite of 2 over 0, which is undefined. Okay, so again, that's undefined. It's different from 0 over 0. It's different from the indeterminate form. It is undefined. And when it's undefined, I need to go ahead and make a little table. I need to check here. I want to be looking at 5 from the left. So I want to go a little bit smaller than 5. So like 4.999 maybe would do. And I'm just going to plug it in and see what I get. Again, I want to factor this if I can. It's not required. I just think it's really helpful. This is x plus 5, x minus 5, It's a difference of squares. We've seen those show up a lot. I hope that's getting a little bit more comfortable for you. So I'm going to do the opposite of 2 over 4.999 plus 5 times 4.999 minus 5. And so then again, I don't really need to figure out what the values actually equal. I just need to decide if it's positive or negative. So this is the opposite of, don't forget that little negative in front of there, opposite of a positive number over 4.999 plus 5 is positive times 4.9999 minus 5 is negative. So I'm going to end up with the opposite of a positive divided by a negative. So it will be the opposite of a negative, which actually comes out to be positive, and therefore I'm going to positive infinity. My limit approaches positive infinity. So again, when it's coming from the left and from the right, if it comes out to undefined, please find where it is headed. If there is no little left or right on there, you can just say does not exist. But because there's a left or a right on there, I want to know that it's going to positive infinity or negative infinity. All right, so the next section that we're going to look at here is the piecewise functions, and that really scares a lot of people when they see it because they can be a little confusing. There's a lot that's going on there. But when you're doing a piecewise function from the left or from the right, don't overthink it. This is saying I am interested in the piece of this function that approaches -1 on the right-hand side, so on the bigger side. And so when I look at these, this is for values less than -1, so this is the left-hand side. And this is for values that are bigger than -1, so this is the right-hand side. Because this is a little plus here, I'm interested in the right-hand side only. And how do I find a limit? I just plug it in. The limit as x approaches -1 from the right of this function, the limit as x approaches -1 from the right of this function is the right-hand portion value at -1. So the opposite of -1 is 1. 1 plus 3, 4. There's my limit. So don't, again, overthink the fact that this is from the left or from the right. Find the portion of the function that covers that direction and plug it in and get an answer. Okay, so let's see another one of those. This one I am doing on problem number 12. I'm going to be approaching -2 from the left. That's a little minus going on there, so I'm only interested in the left-hand portion. So when I look over here, this tells me this is the function that the function is going to cover for any value less than -2, so that's to the left of -2. And this is the function that, or this is the piece of the function that's going to happen when x is greater than -2, so that is to the right of -2. And so again, because this is a little minus here, I'm interested in from the left. So the limit as x approaches -2 from the left of this function is equal to the left portion, and I plug -2 in, so I get -2 squared plus 6 times -2 plus 8, and then I can figure that out. That's 4 minus 12 plus 8, looks like 0 to me, so my limit is 0. Okay, we got a couple more. The limit as x approaches -2 from the left again, here we are, from the left, that's what I'm interested in. From the left, it's the less than portion, so that's the piece that goes in there. The limit as x approaches -2 from the left of this function is the opposite of -2 squared minus 4 times -2 minus 5, which is the opposite of 4 plus 8 minus 5. That looks like -1. And there's my limit. So I didn't have to do any, I didn't have to draw it, I didn't have to look at it, I just had to figure out which portion I am interested in. And so my last piecewise function is the one where I'm approaching to from the right. The little plus tells me from the right, and so that is the part that is for values that are bigger than 2. Those are all the values that are to the right of 2. So my limit as x approaches 2 from the right of this function is the opposite of 2 over 2 plus 1/2, which is -1 plus 1/2, so -1/2 is my final limit. Okay. So the last section where people struggled a little bit still is when it comes to dealing with those trig identities. And in previous videos, I kind of told you things that you should look for back in your Unit 3 notes and Unit 4 notes. That's the yellow notes and the green notes. You'll find these formulas. This is I can look at this. There aren't a whole lot that you're going to be dealing with. We deal with the Pythagorean identities and the double angle identities. Those are the only ones that we've really looked at. So right here, 1 minus cosine squared, if you think, and I'll write them down again, here's the Pythagorean identities. We have cosine squared plus sine squared equals 1. We also have cosine squared equals 1 minus sine squared, and we have sine squared equals 1 minus cosine squared. And so I just want to look for one that I can use. Well, I could replace cosine squared with 1 minus sine squared right here, or I could replace the whole 1 minus cosine squared with sine squared. Either way, those are two options that I have. I'm going to go ahead and replace the 1 minus cosine squared with sine squared. X approaches 0. This is sine squared over sine, which allows me to simplify a sine out. So I'm going to end up with sine over 1 after I do my simplifying. So I'm doing the limit as x approaches 0 of sine. So I'll plug in that 0. I'm looking for the sine of 0. Remember from back in our days, here's 0. That's 1 comma 0, and my limit there is 0. Oops, gotta put it so you can see it. So I just went ahead and plugged that in. Now I should back this up because I should bring up the fact that if I can plug this in and I can get a value, I don't even necessarily have to do this. Always try direct substitution as your first step. But as you'll see, if I plug that in, I'm going to end up with 1 minus this is, remember, like cosine x squared. That's what it is. So this is the cosine of 0, which is 1. So this is 1 minus 1 squared, which is 0, over the sine of 0, which is 0. And again, that's that indeterminate form. And that indeterminate form, that 0 over 0, is the one that tells me, all right, I need to do some cleanup here. There must be something that I can change. Okay? So when you look at, when you're doing problem number 19, notice that this cosine squared is in there. What you're probably going to want to do is replace it with something that equals cosine squared. And so I'd plug in the 1 minus sine squared, and then maybe I can factor that and take something out. Because keep in mind that when you have 1 minus sine squared or 1 minus cosine squared, that I could write that as 1 plus, I'll just do this one because this one's going to be the same. It'll be 1 plus cosine times 1 minus cosine. So I know that I can break that down in that fashion. Okay? So those are the Pythagorean identities. Again, you're going to be focusing on this one here and breaking it down and seeing what you get, seeing if you can cancel some stuff out. The other one we focus on are the double angles. And so I know you have access to the double angle identities, but I'm going to write them down here. The sine of 2 x is 2 sine x cosine x, and the cosine of 2x is cosine squared x minus sine squared x. Or actually, we could do another variation of that. But again, for your work today, that's the one you're going to be substituting in for the top. I should make that arrow go up there, okay? And then break it down. I know I'm sort of just giving you exactly what you need to do, but that's really kind of what it is. We don't have a whole lot to choose from, and there isn't a huge variety of these kinds of problems really out there, okay? So again, it's one of those situations where the best thing you can do is give it a whirl. All right, so I'm going to jump in here. So now this one is x approaching pi. So if I do direct evaluation, I get the sine of 2 pi times 2 times the cosine of pi over the sine of pi, which is 0 times 2 over 0. Sine of 2 pi is same place as 0 pi, so that's 0. Gotta move that over again. Sorry, I keep doing that to you. Sine of 2 pi is 0. Cosine of pi, oops, that should be times negative 2, because the cosine of pi is negative 1 times 2, so that's negative 2. And then the sine of pi is 0. Doesn't really matter. It ends up being 0 over 0. Again, that's that indeterminate form. And so this is the culprit here, or actually I should be circling it here. This is the culprit, that double angle. I can't do anything with just a regular cosine and a regular sine. It's the squared things or the double angles that you want to replace. Those are the things that you can manipulate. And so I will replace that sine double angle. I'll rewrite this as the limit as x approaches pi of sine of 2x is 2 sine x cosine x times 2 cosine x, that was there, over sine x. I can cancel the sine x out. I end up with the limit as x approaches pi of 2 cosine x times 2 cosine x, which is going to, by direct substitution, or direct evaluation, is 2 cosine pi times 2 cosine pi. So cosine of pi is negative 1. And we'll end up with 2 times negative 1 times 2 times negative 1, or positive 4 for our final limit. Okay, so again, when you're working through, if you can just plug it in and get an answer. Again, little bumps in the road that are going to happen, the indeterminate form where you can cancel something out. An undefined situation where you have to figure out where it's headed. Just do a little checkpoint really close to it, from the right or from the left, a little bit bigger or a little bit smaller. Piecewise, only look at the portion of the function that you're interested in. I'm interested in from the right, so that's for values greater than. If I'm interested in from the left, that's for values less than. And then when it comes to the trig functions, look for double angles, look for squared, things that you can move around and replace and cancel things out. So again, your job is to do the odds. When you finish, just take a picture and share it with me. Good luck and have a great day.